American Space Agency NASA doesn't officially call it so, but in a larger sense the community of astronauts that will soon live and work on the moon could easily be called a colony. That's because there will be members of our species living in a place far away from their point of origin. They'll mostly have to take care of themselves, and they'll use the place as a staging point for an expansion even further, to Mars. And no, this is not some sort of sci-fi wishful thinking, but something NASA is actively planning for. We've known for a while that the Artemis moon exploration program is just a step toward achieving the greater goal of landing humans on Mars. But for this step to be successful, moon missions will require not only astronauts to briefly step on the surface, but also an entire infrastructure that could support human life and activities on the satellite. That, naturally, will require some sort of surface structures to house humans, supplies, and their machinery. We've already seen a number of ideas for such habitats being presented, but recently, NASA made the first true step toward actually researching such an idea. More specifically, the space agency tasked Sierra Space via a contract to study the use of the company's large integrated flexible environment or life on the surface of the moon. The contract, whose value was not disclosed, was awarded under the Next Step 2 Appendix R for lunar logistics and mobility studies. Now, you may have heard a thing or two about life before, and you may be aware that the technology is intended first and foremost to be used in space, in the role of a space station. But the nature of the tech could see it easily deployed on the surface of celestial bodies, as full-blown structures. Life has been undergoing testing for a while now, and the results are more than encouraging. Developed by Sierra Space together with ILC Dover, the same crew that has been responsible over the years for the development of astronaut spacesuits for the American Space Agency, including the ones used during the Apollo program, the tech is truly spectacular. Among other things, the fabric of life is made of the same manufactured fiber that went into the suits, something called Vectron. It's the kind of stuff that has proven it has great thermal stability at high temperatures, and it's highly resistant as well. Vectron forms the outer layer of the inflatable habitat, and right beneath that there is a layer of nylon, designed to protect the third layer, which is made of urethane and is used to keep air inside the habitat. All three materials are tied together by a woven structural restraint layer that, according to Sierra Space, can withstand the internal pressure required for the crew to live and work, as already proven by the several burst pressure tests, and topped by a multi-layer softgoods shield that's supposed to protect the entire structure from micrometeoroid impacts and radiation. The fact that life is inflatable would allow it to be launched in relatively small and inexpensive rockets, and can grow to the desired dimensions when on location, something that could prove godsend on the moon. Technically, the habitat could be scaled to reach whatever on-site dimensions are needed, but as Sierra Space envisions it at the moment, it should expand to reach 27 feet in diameter and a pressurized volume of 10,594 cubic feet. That's about a third of the current volume of the International Space Station. In this configuration, with the interior space divided in 3 floors to hold science labs, robotic workstations, a medical bay, sleep and hygiene quarters, and galley, the life would be able to house up to 6 astronauts at a time, but for long-duration missions on the surface of alien worlds, that number would go down to 4. Technically, though, because several such habitats could be linked together, the sky is the limit in terms of room for astronauts. Sierra Space is in a pretty advanced stage of testing with the life. Back in April, for instance, it conducted hypervelocity impact trials on the material of the habitat. The tests, held at the NASA White Sands Test Facility in Las Cruces, New Mexico, included firing the space agency's .50 caliber 2-stage light gas gun at the stuff in a bid to replicate micrometeoroid and orbital debris impacts. It's unclear how long the study into using life on the moon will last, but before it gets to serve lunar astronauts, the tech will be deployed as part of the Blue Origin Orbital Reef Space Station, where it will be used to house the lab, kitchen, garden, and sleeping quarters for visiting astronauts. At the moment, the launch of Orbital Reef's first component is scheduled for 2027. It will be placed in orbit around our planet as a sort of business park in space, allowing paying customers to achieve whatever goals they may have.